Welcome back to my channel Impart Math Knowledge. This is the continuation of previous video. The topic is about expansions of sin power n theta, cos power m theta in terms of sines and cosines multiples of theta. The problem is prove that cos power 5 theta sin power 7 theta is equal to minus 1 by 2 to the power 11 sin 12 theta minus 2 sin 10 theta minus 4 sin 8 theta plus 10 sin 6 theta plus 5 sin 4 theta minus 20 sin 2 theta. First you assume that x is equal to cos theta plus I sin theta. 1 by x is equal to cos theta minus I sin theta. X power n is cos n theta plus I sin n theta. 1 by x power n is cos n theta minus I sin n theta. Adding x and 1 by x, we get 2 cos theta. Subtracting x and 1 by x, we get 2i sin theta. Similarly, adding x power n and 1 by x power n, we get 2 cos n theta. Subtracting this, we get 2i sin n theta. Now we take LHS. LHS is cos power 5 theta, sin power 7 theta. This can be written as 2 cos theta power 5, 2i sin theta power 7. This is equal to x plus 1 by x to the power 5, x minus 1 by x to the power 7. We expand the right hand side using binomial theorem. The left hand side is 2 to the power 5 cos power 5 theta, 2 to the power 7 I to the power 7 sin power 7 theta. That is 2 to the power 12 I to the power 7 cos power 5 theta sin power 7 theta. We know that I square is equal to minus 1. So I to the power 7 is I square into I square into I square into I. So I to the power 7 is minus I. Here the total power is 12. Like previous problems, we can use Pascal's triangle. Here we have cos power 5 theta sin power 7 theta. The total power is 12. So we have to write 12 terms. In this case, sin power is 7. So in the 7th term, we are supposed to change the sign alternatively. 1, 1, 1, 1, 1 plus 1 is 2, 1, 1, 1 plus 2 is 3, 2 plus 1 is 3, 1, 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1, 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, 1. 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6 and 1. Next term 1 plus 6 is 7, 6 plus 15 is 21, 15 plus 20 is 35, 20 plus 15 35, 15 plus 6 is 21, 6 plus 1 is 7 and 1. Sin power is 7. So in the 7th term, we change the sign alternatively. Minus 7, minus 35, minus 21 and minus 1. Now we repeat the process. 1 minus 7 is minus 6. Minus 7 plus 21 is 14. 21 minus 35 is 14. Minus 35 plus 35 is 0. 35 minus 21 is 14. Minus 21 plus 7 is minus 14. 7 minus 1 is 6 and minus 1. 1 minus 6 is minus 5. Minus 6 plus 14 is 8. 14 minus 14 0. Minus 14 plus 0 is minus 14. 0 plus 14 is 14. 14 minus 14 is 0. Minus 14 plus 8 is minus 8. 6 minus 1 is 5. Then minus 1. Now 1 minus 5 is minus 4. Minus 5 plus 8 is 3. 8 plus 0 is 8. 0 minus 14 is minus 14. Minus 14 plus 14 is 0. 14 plus 0 is 14. 0 minus 8 is minus 8. Minus 8 plus 5 is minus 3. 5 minus 1 is 4. Then minus 1. Now 1 minus 4 is minus 3. Minus 4, 3 is minus 1. 8 plus 3 is 11. 8 minus 14 is minus 6. Minus 14 plus 0 is minus 14. 0 plus 14 is 14. 14 minus 8 is 6. Minus 8 minus 3 is minus 11. Minus 3 plus 4 is 4 minus 1 is 3, minus 1. Now 1 minus 3 is minus 2, minus 3 minus 1 is minus 4, minus 1 plus 11 is 10, 11 minus 6 is 5, minus 6 minus 14 is minus 20, minus 14 plus 14 is 0, 14 plus 6 is 20, 6 minus 11 is minus 5, minus 11 plus 1 is minus 10, 1 plus 3 is 4, 3 minus 1 is 2, and minus 1. The highest power is 12. So we have to write the even numbers like 12, 10, 8, 6, 4, 2. This is x to the power 12, 1 by x to the power 12, x to the power 10, 1 by x to the power 10, x to the power 8, 1 by x to the power 8, x to the power 6, 1 by x to the power 6, x to the power 4, 1 by x to the power 4, x square, 1 by x square, then constant term. Now we can write this as 1 into x to the power 12 minus 1 by x to the power 12 minus 2 x to the power 10 plus 2 1 by x to the power 10. Then minus 4 x to the power 8 plus 4 1 by x to the power 8 plus 10 x to the power 6 minus 10 1 by x to the power 6 plus 5 x to the power 4 minus 5 1 by x to the power 4 minus 20 x square plus 20 1 by x square. Constant term is 0. I can write this as x power 12 minus 1 by x to the power 12. Take minus 2 outside. X to the power 10 minus 1 by x to the power 10. And take minus 4 outside. X to the power 8 minus 1 by x to the power 8. Then take plus 10 outside. X to the power 6 minus 1 by x to the power 6 plus 5 x to the power 4 minus 1 by x to the power 4. Then take minus 20 outside, x square minus 1 by x square. When you are simplifying this term, make sure that all the terms contain same sign, like x minus 1 by x or x plus 1 by x. We assume that x power n minus 1 by x power n is 2i sine n theta. So x to the power 12 minus 1 by x to the power 12 is 2i sine 12 theta minus 2. X to the power 10 minus 1 by x to the power 10 is 2i sine 10 theta minus 4. X to the power 4 minus 1 by x to the power 4 is 2i sine 8 theta plus 10. X to the power 6 minus 1 by x to the power 6 is 2i sine 6 theta plus 5. X to the power 4 minus 1 by x to the power 4 is 2i sine 4 theta minus 20. X square minus 1 by x square is 2i sine 2 theta. Now cos power 5 theta sine power 7 theta is equal to 1 by 2 to the power 12 I to the power 7. Here 2i is common for all the terms, so take it outside. 1, 2 getting cancelled. So we get 2 to the power 11. 1, 2 getting cancelled and 1i getting cancelled. So we get I to the power 6. I to the power 6 is nothing but minus 1. So cos to the power 5 theta sine to the power 7 theta is equal to minus 1 by 2 to the power 11 sine 12 theta minus 2 sine 10 theta minus 4 sine 8 theta plus 10 sine 6 theta plus 5 sine 4 theta minus 20 sine 2 theta. From Pascal's triangle, we can easily arrive at the solution. Next problem, prove that cos to the power 4 theta sine cube theta is equal to minus 1 by 2 to the power 6 sine 7 theta plus sine 5 theta minus 3 sine 3 theta minus 3 sine theta. As usual, we write x is equal to cos theta plus I sine theta. 1 by x is cos theta minus I sine theta. x power n is cos n theta plus I sin n theta. Adding x and 1 by x, we get 2 cos theta. Subtracting this, we get 2i sin n theta. Similarly, adding x power n and 1 by x power n, we get 2 cos n theta. Subtracting x power n and 1 by x power n, we get 2i sin n theta. Here left hand side is cos power 4 theta sin cube theta. So we can write this as 2 cos theta power 4, 2i sin theta power 3. That is x plus 1 by x to the power 4, x minus 1 by x to the power 4. So this can be written as 2 to the power 4 cos power 4 theta, 2 cube I cube sin cube. That is 2 to the power 7 I to the power 3 cos power 4 theta sin cube theta. We can use Pascal's triangle. So total power is 7. In this case, sin power is 3. So in the third term, we have to change the sign alternatively. And then we proceed till 7th term. 1, 1, 1. 1, 1 plus 1 is 2, 1, 1, 1 plus 2 is 3, 2 plus 1 is 3, then 1. Third term, change the sign alternatively. Then 1 minus 3 is minus 2, minus 3 plus 3 0, 3 minus 1 is 2, then minus 1. 1 minus 2 is minus 1, minus 2, 0 is minus 2, 0 plus 2 is 2, 2 minus 1 is 1, then minus 1. Then 1 minus 1 is 0. Minus 1, minus 2 is minus 3, minus 2 plus 2 is 0, 2 plus 1 is 3, 1 minus 1 is 0, minus 1. Then 1, 1 plus 0 is 1, 0 minus 3 is minus 3, minus 3 plus 0 is minus 3, 0 plus 3 is 3, 3 plus 0 is 3, 0 minus 1 is minus 1, then minus 1. Highest power is 7. So we can write the terms like 7, 5, 3 and 1. The highest power is 7, so you have to write the terms like this. We can expand the term using Pascal's triangle. From Pascal's triangle, we can write 1 into x to the power 7 minus 1 by x to the power 7 plus x to the power 5 minus 1 by x to the power 5 minus 3x cube plus 3 into 1 by x cube minus 3x plus 3 by x. Simplifying this, x to the power 7 minus 1 by x to the power 7 plus x to the power 5 minus 1 by x to the power 5. Take minus 3 outside. X cube minus 1 by x cube. Take minus 3 outside. X plus 1 by x. And we know that x power n minus 1 by x power n is 2i sin n theta. So x to the power 7 minus 1 by x to the power 7 is 2i sin 7 theta. X to the power 5 minus 1 by x to the power 5 is 2i sin 5 theta. X cube minus 1 by x cube is 2i sin 3 theta. Minus 3 2i sin theta. 2i is common for all the terms, so take it outside. Sin 7 theta plus sin 5 theta minus 3 sin 3 theta minus 3 sin theta cos power 4 theta sin cube theta 2i by 2 to the power 7 I cube, and write the remaining as it is. One by 2 to the power 6, I square is minus 1, and you write the remaining as it is. So cos power 4 theta sin cube theta is minus 1 by 2 to the power 6 sin 7 theta sin 5 theta minus 3 sin 3 theta minus 3 sin theta. For finding the powers of sin and cos theta, first you assume these terms. After that, apply Pascal's triangle for expanding the right hand side. Then apply Pascal's triangle. After applying the Pascal's triangle, simplifying the term, we get the required solution. Check my previous video for sin power n theta and cos power n theta problems. Hope you all understand. Thank you for watching.